Hi, I'm Michal Vasicek, and I would like to present you Forge Design Automation Basics. I'm working for Autodesk for almost 4 years. My current main responsibility is to make Inventor valuable part of Forge Design Automation. Why you should be interested in Forge Design Automation? You have models created in 3ds Max, AutoCAD, Inventor, or Revit, and you would like to bring them on your web. Or you have some workflows you would like to automate on top of your model data. I'll do a demo using Forge Design Automation extension installed inside a Visual Studio Code. It's the best tool for playing with Autodesk Forge, and it's also great for building your proof of concept. To understand Forge Design Automation, you need to understand some basic terms: activity, alias, Workitem engine, or a bundle. We will start with cornerstone of Forge Design Automation. These are activity, alias, and Workitem. What is the concept of Forge Design Automation? It's simple. Forge Design Automation can run program for you, and by program I really mean Windows EXE. Let's open Visual Studio Code to create our first activity. You can see two lists of activities. Shared activities, these are created by Autodesk, and own activities, these are created by you. Our activity will be called timestamp letter. It takes letter as an input, append timestamp at the end of the letter, and produce stamped letter as output. Activities can have inputs and outputs. It's the same as function. You feed your function with input parameters, and function can produce multiple outputs for you. In the most of the cases, in design automation environment, inputs and outputs are files. Input files are downloaded during running the activity and named as you define in local name. Hence the get, as it is HTTP verb for downloading content. Then you can define what file you would like to upload back as a result. Hence, the put, as this HTTP verb is for send data out. Again, you can specify name of the file in local name. In our case, it's again letter.txt, as we will modify original downloaded file with timestamp. Last thing we need to do is to define our command line. We want to use cmd.exe as a program. Every Windows contains it, so we will leverage it. As we will not need other things, let's delete them from our activity. We will talk about them later. And confirm activity creation. Activities are versioned. To run the activity, we have to name our version by creating alias, pointing on version we are interested in. Let's name our alias test and point it to our first version. Run our activity means to create work item. We are asked to provide our parameters. We have to think where to get input letter. I have one on my local drive. It needs to be uploaded to cloud storage. Design automation needs to be able to access the file across internet. Let's upload it to our OSS storage. File is uploaded, but it's private. No one except you can access the file. You can create temporary secret link. This secret link given to anyone can be used to download the file. We will provide the link as the parameter for our work item. We are asked what permissions we are giving for visitor of the link. For input parameters, read is enough. Now copy and paste URL. What about the result? We would like to allow design automation to upload resulting file to OSS. For this, we can create empty object on OSS. And again, make it available for everyone by creating temporary secret link, this time with write permission. And copy paste URL. Run our work item. Work item succeeded, and we can take a look at the report. Report contains some details about work item processing. It's also useful when work item fails. Now we can download our letter with timestamp from OSS and check if our work item did what we wanted. Great, we have the letter with the timestamp done by design automation. As I said, running activity means to run a program available on design automation machine. CMD.exe is not the reason why we created design automation. We created it because we wanted to allow you to leverage power of engines on cloud, like 3ds Max, Inventor, AutoCAD, or Revit. Here is new activity which will run Inventor. An Inventor will open input model. Let's call it open model. We have to pick proper engine to make sure our processing machine will have engines program available. As you can see, design automation have various versions for particular engine. I'll pick Inventor 2021 since this is the latest available Inventor engine. One parameter called input model with get HTTP verb because it needs to be downloaded, and delete not needed stuff. We need to locate Inventor program on the machine. There comes command line variable expansion. We can use $engine.path variable which represents path to folder with Inventor. Then we can specify Inventor core console exe which sits inside the folder. We ask Inventor core console exe to open model using switch I, and we need to specify full path. If we would specify just file name as relative path, that wouldn't be enough. This is time to show another variable expansion. Inputs are files, so we can reference these using variable args, and inside the squared parentheses, we specify name of the parameter and then we specify we want path of the parameter. Variables referencing file path needs to be inside double quotes. Create activity, create alias so we can run the activity. We need to upload our model to OSS and create temporary secret link for Workitem. Since we just opened model using Inventor and we haven't done anything with design, we don't have any result file. To check if we did everything well, we need to take a look at report. There you can see Inventor server started and opened our design. How to do something with design is not part of the demo, since it's a little bit different for each engine. In next presentation, I'm talking about details for Inventor engine. Next step would be to demonstrate you usage of the AppBundle. AppBundles are a natural way of how to extend engine's behavior. Every engine uses different technology to create the extension, so I'll cover AppBundle from different perspective, which helps you understand AppBundle's role. I told you design automation run the program for you. I showed you how to run CMD.exe or how to run engines program like Inventor. Now we will use our own program. I have prepared small random number.exe which, as you can see, creates result.txt which contains random number inside. Let's do this on design automation. I need to prepare a package, which is zip containing our random number.exe and one special file called package contents.xml. Package contents XML normally contains description of your engine extension. Since we are packing custom exe, we can keep it this simple, but it needs to be present. Let's zip both files so we can create a bundle called random number. Pick the package zip file from disk. AppBundles are also versioned, and to use them, there needs to be alias pointing on our first version. Activity time. We will call the activity random. Our activity has one output parameter called result with put verb, sending file called result.txt. Now let's select our AppBundle we want to use in this activity, random number plus test, which points to our first version. Last is the command line, and here is another variable expansion. We need to locate our random number exe. We can use AppBundle's dictionary with name of our AppBundle as a key, and give me the path to bundle folder. Then just append the name of our exe file. Create, and don't forget alias. create work item, prepare empty object for our result, temporary secret URL with write permissions, and run. Download the result and see there is our random number. Now let me show you different type of parameter. A random number program produces random number between 0 and 50. If we provide command line parameter with different number, we can change upper limit. Let's try it on our local computer. I will run random number exe again, but this time I will add one command line parameter, 5 million. When we check result.txt, we can see there is much bigger number. What if I would like to be able to change upper limit for each of my work item? We must create new parameter and let's call it max. Since the source of the value is not file, we choose read and not get as the verb. To use result value on the command line, we need to specify variable expansion for the max parameter. It's similar to what we have done with inventor opening the modal. $args max, but this time not the path, but value. Create activity and change the alias. When filling values for work item, we can just fill number 5 million. Now download the result and check if the number is higher. Let me show you something which can help you to write automation of what I showed you or develop integration of design automation into your current software. In other words, you need to create AppBundles, activities, and work items programmatically. You can learn how to use API from our documentation. But there is also other way. You can use local proxy debugging tool like Fiddler or Charles Proxy. When you run them before you run your Visual Studio Code, they can catch all the communication between Visual Studio Code and Forge design automation servers. You can then go and take a look how the communication looks like. What creation belongs to what API call. You can take a look at the details of the call, format of the request, and more. If you write your program and something doesn't work for you, you can compare how our tools calls the API. Let me summarize what we have learned. To run something on Forge Design Automation, you need to define activity. Center of the activity is the command line, which defines what program and how to run it. Activity also defines what are the inputs and what are the outputs. In most of the cases, inputs are files your program needs to use, for example, inventor modal. And outputs are also files your program produce. Activities are versioned, and to run the activity, we must define alias inside the activity which points on version we would like to execute. By execution of the activity, we mean creating work item. Into the work item, we must specify where to download inputs and where to upload outputs. Forge Design Automation was done because it offers engines of 3ds Max, AutoCAD, Inventor, or Revit in various versions. These are also just programs available on Design Automation. To make sure engine program is available in your activity, you have to specify proper engine and its version in the activity. If you need to execute your own binaries, either as exe or as the extension of the engine, you have to deliver it to Design Automation. For these purposes, we have AppBundles. You create a bundle with your binaries inside. AppBundles are also versioned, so to use them, there must be created alias inside the AppBundle, pointing on version you want to use. In activity, you can define the AppBundle you want to use. Then your binaries are available when running the activity. I hope you enjoyed our session and everything was well understood. There is more about Forge Design Automation. So make sure you check out our documentation. Thank you.